Alright guys, so this is a second derivative equation, parametric equation problem. We're looking for the second derivative in terms of t. The couple things that we need to do is first the first derivative, so dy dx equals dy over dt, and dx over dt divided by dx over dt. So make sure this is a must. You must know this. Okay, so we could do each derivative. So look at dy over dt, and you're taking the y function in terms of t, and you're taking the derivative in terms of t, and then we're doing the same thing with the x function. So we'll have d over dt for the x function. And again, picking this was on purpose because you need to remember your exponential derivatives, which this would be 9 to the t ln 9. It's always whatever the base is, you keep the function the same, and then this is 3 to the t ln 3, and then we know derivative of constant is 1. Now, simplifying this, you're going to need to change a few things here. This and this I'm going to change, just using properties. 3 squared is 9 raised to the t, and then I'm going to change ln 9 to ln 3 squared. You'll see why I do this in a second. Trying to make this simple for us. Again, going back to the exponent rule is going to go down in front. Front. And now we have 3 to the 2t, another exponent rule, times 2 ln 3 over 3 to the t ln 3. Now if you notice, we got some cancellations here, and then we could simplify that because you can subtract your exponents, and that'll give us for dy over dx 3 to the t times 2. I just like to write it this way, keeping the constant in front. And we'll use that coming up. Okay, so now what we need is d squared y over dx squared. Remember this, d over dt of dy over dx, and then dx over dt. So again, a must know this as well. So here we go. Now take your derivative from the first derivative, right? Take the first derivative, plug in, and you're doing the derivative with respect to t, so it's going to look like, I would just write in this notation to help us. And then we already had dx dt, so again, dx dt is right there. You can take that, and I don't really have to do much with it, I just have to leave it for now. So here then, your derivative of 2 times 3 to the t, 2 is constant, and now use your properties of exponential, so it's 3 to the t ln 3 divided by 3 to the t ln 3, and nicely cancels out, and you get 2, and that is your second derivative.